So, hi everyone. I am Beausoleil, also known as BarZoule, also known as Buzz or Bo. So this is me. And this is Polaris.
Also known as Dave, albeit it freaked out my wife when I got mail to my house with the name Polaris on it. I am the founder of the Northern Dragons demo group and co-founder, as was mentioned, of In4K. And I do not do demos in my day-to-day work. That's just for fun and something that I enjoy doing, and I've enjoyed doing for a very long time. In the mid-90s, I enjoyed watching demos, and then I transitioned to making demos and going from there. But Northern Dragons got its start in 2001, really because for me, making demos is really about childlike wonder. You know, you have certain beliefs about what a machine is capable of, and when you see a demo that does something that is inspirational on the architecture of the machine, it challenges your beliefs of what you think that machine is capable of, and it does it in a really, really beautiful way. And for me, that has that certain awe factor that cannot be helped or cannot be ignored. So I couldn't help to be a demo fan, and in some part because maybe I'm insane, I don't know, I decided to move from fan to producer in 2001. And an interesting thing happened. You know, you decide, okay, I'm going to make a demo, I'm going to attend an event, and maybe I know for one gentleman this is his very first time submitting anything, so let's hear a round of applause for that. I was talking with him earlier. So what you're going to experience after that is what I call a near-death experience, quite simply, right? Because it's like, oh, we're going to make a demo, it's going to be amazing, we're going to do this stuff. You go to the party, you submit the worst thing you have probably ever written in your life up until that point, right? Because you want to submit something. It's not what you dreamt it would be, but you eventually just buckle down and you actually submit something. And then afterwards, you know, it's like, oh, that was cool, and you know, the event was great, and so on. But then you sit there and say, do we continue? And the same thing happened with the Northern Dragons being established in Canada. We traveled to Helsinki for our very first demo party. It's a little expensive, as I'm sure everyone who's traveled from further afield has personally experienced. But then you say, okay, what do we do next, and do we continue making things? And the answer for us came to make an intro. I mean, after all, an intro is only 4,096 bytes, right? And that little dot right there, we're going to talk about that dot, because that dot represents 4,096 bytes, 4 kilobytes, or 0.0039 megabytes. But to put it in perspective, that larger grid is representative of an 8.63 megabyte demo. Now that is a really, really small demo. The NVScene guidelines say, you know, please keep your productions to 128 megabytes or less, please. Nowadays, it's not unusual to see, you know, maybe 20, 30, 40 meg demos. And I think the one we're working on is going to be what size in the end?
Around 50.
Around 50. So this puts it in perspective. Another way of looking at it, 4 kilobyte intro is equivalent to a 64 by 64 grid of 8-bit values, or you can think grayscale. So if I took a normal picture and I said, hey, I just want to make this picture 4K in size, 4 kilobytes in size, that's all you can represent. That's how much data you have to play with. And that doesn't include code to display or render anything, doesn't include code to put anything on this into the sound buffer. That's just what 4K looks like, to put it in perspective. So to say that we were maybe a little naive to think, oh, you know, it's only 4,096 bytes to make an intro is maybe a little bit of an understatement, but it started us on a journey. And in fact, it's a journey that lasted many different productions. That is our very first 4K intro right up there called Trees. Procedural generation without shaders. But that was back in 2002, written entirely in assembly language and then crunched down using UCL algorithm. Then we had Forest, which I wrote in an airport because I really wanted something for an event that was in North America. It's terrible please ignore it. The Ethereum, which was written and released in assembly the same time frame, so 2003, which was also entirely written in assembly language. Then Zero, which was a 4K text mode production. Evolutio, which did cab dropping as a technique, released at assembly. Cubetro, which I should mention is a 12 kilobytes production, so it's still pretty small.
But we cheated.
Yeah, we cheated. But we also entered it into a combined demo compo, which is its own kind of insanity. So oftentimes in North America, there's events that have a intro and demo compo combined. So you may be up against something that was that big grid, right? Like 9 megabytes in size. So we made a valiant effort to win that compo. It got second place at 12K, so very proud of that. Story's not over yet. You know, we ended up doing Blobzilla 4000, which was 4,000 bytes. We actually made it exactly 4,000 bytes.
Yeah.
Open
Just
it up
for
in
a challenge.
Just for a challenge, and actually open it up in text editor. You can see the secret message in the back of the file. Cataract and step back. And all of these things ask different questions. You know, can we do trees? Can we make procedural planets? Can we evolve character animation? And we went through this. Each one had its own design process, but there's one in particular that we released in 2002, which released at Party, and there's a lovely promotional poster for at Party right over there, so you are hereby all invited. I'm sure Val would love for you to attend at Party as well. Hands in the air, there you go. So we released that at Party, and it's a 4K, and it's a pretty nifty one, and I just realized I think there's been a bit of a mistake, because you're going to need something special to experience this 4K. Gloom, can you please distribute the glasses for all? You know, maybe we can do a few forks in the road. You know, you give it to somebody to give out half the pile, and they give out half the pile, and we can optimize the algorithm, right?
Parallel processing.
So just press the next slide to get the...
Yeah.
Yeah, so when you receive your glasses, if you can put them on, so that way we know you've got them, that would be fabulous. Sure, we can do that.
Glasses missing.
Hands in the air if you're missing. Otherwise on you. All right, blackmail picture. Oh, here we go. Everybody say cheese. I only got half the room in that one. I'm going to have to use panoramic mode or something. Everyone's going to have to stay still. What the heck? All right, that is awesome. Oh, you always blink. Can't see it behind the lens anyway. So,
Yeah.
All right, so for your viewing pleasure.
Yeah, let's go. Thank you. So this was Wicked, and we will tell you about why we did it for at Party and all the creative process behind that, why we did something that looks like this. The big question, like Polaris was saying, entering an intro in a demo compo is a big challenge. And so the question was, why do a 4K for at Party? We would go against bigger demos maybe or stuff. But the question starts with why making a 4K? Because maybe some of you in there are just questioning why would someone do that? There's for the challenge, everything, but mostly doing a 4K is great fun. It's less complex. It involves lots of maybe tricks, sometimes fun stuff. But the nice thing with the 4K is that it's like a demo in concentrated form. It's all about algorithms. It's about generating content. It's not about firing up your 3ds Max, Photoshop, or whatever, and doing lots and lots of hard work just to have something decent on the screen. It's way more different than, say, video games than a demo would be. It's more closest to the platform itself also, and it also takes less time. When you know your shit, if you've got a framework already, if you have any idea of what you want to do, it can take much less time. You will not be fiddling with normal maps, trying to fix maybe a light map that you want to bake somewhere and it bugs in some place and you restart your baker and wait for 12 hours. No, it's faster. And also, since it's so small, it compiles instantly. Unlike some demos, sometimes you've got tons of libraries and you hit compile and you wait for 5 minutes. If you do your shit well, it can save you time. So yeah, for at Party, we didn't have much time, and we wanted, we had ideas. I at least had mine on the sound side, and some stuff we wanted to try. So we're like, why not? Let's do a 4K in the demo compo. At Party is a nice place for that. We knew the audience, we went there before, and the people in North America maybe more than other places, or maybe at Party more than other demo parties. The audience is not so much about the latest technology. A lot of people release really old school demos there. There's also a lot of intros. So it's much less focused on big Windows demos and video game wannabes than maybe other places. So we did one, which is what you saw. And there was this big question. We want to make a 4K intro, but what are we gonna do? So this gentleman here.
Guilty, yeah. Everything starts with a question. Hey, maybe we should do this, or could we do that, right?
He found that. On some shady website, they were selling those by the dozen for really cheap. So he came to us, and what did you tell us? Something like...
I told you I ordered a big amount, and I was hoping that they would arrive before we got there, and it arrived like a week before the party. So we were very fortunate.
So like, we need to make a 3D demo. It will be awesome. 3D intro. We're actually wondering if that shit already, if it was done already, this idea of doing 3D in Montreal, and yes, it had been. So we researched, we looked at everything that has been made, and we wanted to make something different, but we also had an opportunity to see what worked and what didn't work. So just by the idea of exploiting that concept of 3D, which isn't an idea for content, it's merely a way of visualizing the thing. It brought tons of restrictions that lead us to have something that looks like what we did. So there was Blacklight, who does plane simulation for a living, and he had 3D in his software. So he had a lot of knowledge of what goes well in 3D with 3D glasses. So there's high contrast, which is really, really important. If you do just blurry stuff, both eyes will see the same thing. Wireframe is also very good because this is high contrast on very limited area. So it's very good. This is what gave us the approach of having something really, really high contrast with wireframe where we need it. So all the aesthetic was kind of made for us because of the limitation of the medium.
Okay. So I'll get into the caution in a moment, but to begin, I'll mention that it's a mixed audience that we have here. We know that some people are like, oh, how do you make demos? And other people are, how do you make intros? And some people are, looking for something different from this talk. So we're going to dive into some of the most fundamentals of 4K intro making, but we're going to do it very, very quickly. At the end of the presentation, we have our email addresses up. Also, I'll be around to chat with, and Beausoleil as well later to chat with as well. So this is going to be like light speed through some of the most fundamental parts of 4K intro making for those that haven't seen it before and have some questions, while maintaining the interest of those that have done it a dozen different times. The other thing that I'll mention, and it comes with a little bit of a story with it, is danger spoilers ahead. I was having a conversation with Trickster, who's in the audience, and he's going to be wondering where the heck I'm taking this. But he was asking me, as a 4K intro developer, like, how do you make sound? And Trickster has developed a lot of things on the DOS platform and back with sound cards. And I was telling him that, well, actually, we do it really simply with most 4Ks. What we do is we allocate a huge gob of memory. And we put a wave header right in front of that memory, and then we render all of our music to it right at the beginning of the production. And then we just use a play sound routine, point it to the pointer of that memory, and start the production just like that. And the poor guy looked like I just told him there was no Santa Claus, because he thought there was something way more intricate with that. And we're going to touch on something later that will be a little more redeeming. There is a little bit of a Santa Claus. Trickster, thanks. But it's one of those things where it's like a magic trick or something, right? Once you know the mechanism, once you know what's going on behind it, it falls into one camp. It's either cool, I want more because it's really artful or something. But if it's based on something, remember, like a really good demo challenges your belief of what's possible. And when you have this thought about what's possible, and you find out that your belief was maybe something, I don't want to say trivial, but it was like, oh, actually, it's not quite like that. It's like this. And then you look at it and say, oh, it's so easy, right? Like, it can be a bit like stealing Christmas. So if anyone doesn't want an experience of spoiler at all for 4K, I wouldn't blame you for leaving. No problem. Okay.
Well stayed.
So fundamentals and fundamental tricks, as Beausoleil mentioned earlier, think algorithmically, calculate, don't store, which kind of has a side part of do evil things. Allocate memory, don't release it, right? Things of that nature. Let the operating system clean that up for you. It's 4K. You're allowed some leeway. Don't test for error conditions, that kind of stuff. You can create or find a graphics framework, and if you need one in 4K, just Google it. You'll find lots of content on there. And ours has been rewritten 4 different times over the years, and we have DirectX frameworks and we have OpenGL frameworks, but they basically do the same thing. They allocate your graphics resources, set up your video mode, set up a render pump, so they consistently just call the render pump, it should be around 600 to 700 bytes at most, but ours arrived to the point where our make file resulted in the debug mode not working, which is a real pain, but yeah. I've since fixed that. I got rid of the make file. I have a new version.
Great.
Yeah, it's awesome.
We'll have to do a new intro for that.
We will. We will. This is a conventional programming approach. This is the sort of thing, if you were to look up tutorials on OpenGL, that you'd find. And you can see that you've got on the left the Windows rect being set to certain values. You've got all these setup things happening, and then you register a Windows class and you create a window and so on. But this is the sort of thinking you need to get away from for 4K, because if you have your 4K hat on, that looks like this, and that's it. That is all. So that achieves the same result of all of that by leveraging the existing edit Windows class. So those are the types of things that you need to think about for 4 kilobyte thinking. And the very last sort of fundamental I want to mention is we've had an evolution in the 4K intro area. The very first Trees production, that was the very first one that was released at Assembly 2002, post Northern Dragon's near-death experience. The object code for that is just over 7,000 bytes. The executable is about 5.5 kilobytes. The executable compressed using UCL, which was what we had at the time, is exactly 4,096 bytes. You can use a COM approach using APAC to drop that down, dropping a file on the local operating system. That will bring you down to 3 kilobytes. And then maybe you do cab dropping, another thing which we've also done over the years, 2,300 bytes. And then Crinkler, which combines compression with linking using context modeling, which is an absolutely amazing gift for the 4K scene. And I'd really selfishly like to ask for a round of applause for Crinkler, because it's great stuff. And I'm sure that the authors of Crinkler would know that we appreciate it very much.
There's tech on the framework, but also on the sound side. I've been doing sound tech for intros pretty much since I joined Northern Dragons. I just thought it would be cool to play with sound. And I'm kind of disappointed when seeing how much the sound in 4K intros use often the same thing, stuff like Forklang, which seems wonderful, but make your own sound engine, people. It's fun to make. For this one, we kind of changed the approach. We did a MIDI converter because in the past I did tons of tools, maybe one tool per prod, some kind of trackers, others more like stuff like Fruity Loops, stuff like that. But at the end, I realized one thing is that it's not the one who made the tool who will use it to create the sound. If I would be our musician, yeah, why not? But in this case, Salkin did the music. So you want your musician to be the most efficient. So if he can use his home tool, that's a major plus. So we did a MIDI converter. Why MIDI? Because everything can export MIDI. He was using a modblock tracker, and you've got a MIDI export. So it was working pretty well, except for little bugs. And it's all right to have a buggy tool. We're not in a production company or whatever. So you do something that works 90%, and fixing the last 10% will take much less time than fixing it. Fixing it will take the same amount of time than bringing it up to the 90%. So, just saying.
There is a Santa Claus, Jim, really.
Yeah.
This is where we get into it.
We found a way to do some nifty trick. With the play sound, there's the bad situation where you launch your intro and it's kind of sad because you've got to wait for 1-2 minutes because it's just generating the whole music. So what we did is that we skipped that. Play sound, it just asks for a pointer to data to playback. But why if you send it the buffer before you actually fill it? It works! So as we render the actual production, we generate the music at the same time. You've got to reorder sometimes our stuff, but we could do that with, it was around maybe 100 bytes, maybe less. So that was our little Santa Claus. And there was also graphic tricks along with the audio tricks. We wanted to make good-looking graphics, so we started with cubes because, well, it's the Demomaking, it's fun to see cubes. But at a point, we wanted to make tunnels because when we did all our researches, we saw that tunnels is really effective with the 3D glasses. But to make a tunnel with cubes, it's not so interesting. I wanted more variety and everything. So we had already text in our production for the titles and everything, and we had the idea, why not use winding? It got shapes.
And even the cube.
Yeah, you see the last character? It's our cube. Yeah, so we were just generating characters. What you see is, we could say, a new school ASCII demo. Yeah, so those shapes, if you call with a really low resolution, it will give you stuff like octagons from the circles. You can set the resolution. So we had fun with that to just deconstruct the characters so that they wouldn't look too much like windings. And it also helped to have a really good wireframe that wasn't too dense. So for the rest, we used another font, Impact, because it looks good and was fat enough, so readable, black and white. So the aesthetic, it all came from, like we say earlier, all came from what looks good. There wasn't much of choices. It was, let's do the best we can. So it gave that. Like Antoine de Saint-Exupéry said, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And that's a bit what we did with this production. We kind of, and it's what you're forced to do with any intro. You don't have the luxury to just add stuff over and over and over. You're forced to be a little bit minimalistic. Sometimes it can save you.
Continuing on that, the artistic value of having those restrictions led it to having a very cohesive and specific feel, which I think is the reason why it is one of my absolute favorite productions that we've ever produced. So thoughts about the future of 4 kilobytes are some interesting things. This is what the 4 kilobyte scene looked like in 2002 when the Northern Dragons released its first ever 4 kilobyte intro. And in 2013, obviously we haven't finished 2014 yet, but the scene has changed. So primarily it's a Windows scene now. In addition to that, things are actually getting better. If you chart the number of thumbs up in the demo review site, Puit, among other things that it does, versus the number of thumbs down or the it's okay, we're actually trending over year to year, making better and better 4 kilobyte productions, which is really a great place to be. So if the past is anything to go by, we definitely have some outstanding stuff to look forward to in the 4K scene and the 4K space. And some final trivia.
Yeah, just fun stuff. The YouTube captured version is nearly 60 megabytes. It doesn't compare.
I tried really hard, but that first picture, right? Like I had to pick a 9 megabyte demo just so you could stand a chance of seeing the little dot.
Yeah, so you get to imagine like 6 times. Other trivia. Yeah, the party version had the 3D def reversed.
Whoops.
No one realized, so who cares? And there's a lot of stuff we changed for the final version, because as soon as we saw that as soon as we realized that the def was reversed, we wanted to fix it. While we're fixing it, we'll make it better. We didn't have the credits in the party version, so we added, and we added a couple of other stuff like that. I think I added some reverb in the sound, but there's also stuff we removed because it's optimization. As I knew that the music wouldn't change, I just made the volume level good enough to have no clipping, so I removed the clipping safety. Little tricks like that. It saves a few bytes. A couple of numbers, because it's all about compressing the data with the packers, crinklers, and all of that. So if you have a float number or any other kind of number, if they are, I like to call them square numbers, like power of 2. It's going to use less bits. It's going to be more repetitive patterns, since it's all more or less the same, 2, 4, 8. There's just one bit open in the field. Same for the fraction 0.25, 0.125, 0.625. You're better to round your numbers to that, and you can save 1, 2, 3 bytes at a time. But when you add them together, it gives credits at the end. So a lot of little optimization. And yeah, and stuff like that. If you have questions...
if you have immediate questions, ask them now. Don't be shy.
Yeah.
But if you have anything after, you're always welcome to chat with us, and also toss us an email.
So we've had the usual thing, questions, hands up. Anyone? Oh, okay.
Awesome.
Keep your hands up, because I can't find you otherwise.
Yeah. We'll wait for him to arrive with the mic.
What compiler do you use?
Okay, so actually, hang on. Just give me a moment. That's also a great question, because when the Northern Dragons first started with it, we ended up using Massum32 basically for our very first few productions, and I can talk about a few of them. Okay, there you go. So yeah, Massum32, and this was around the time that cab dropping started to become a technique. And what cab dropping is about is that COM file dropping, pardon me. So the executable header within the Windows environment has a lot of fields that are required, and unfortunately it has a lot of fluff in it. And so what you can do as a technique is the COM file format, which is the MS-DOS original executable format, is basically just give us your instruction pointer, give us your code, we're good to go, right? It's also limited to being 64 kilobytes in size. So what the COM file dropping did was it ended up taking a little bit of a stub routine that you write in assembly, and you add your actual production after that, your executable, and then you write it out to disk. And then after you've got this, basically a file dropper that writes your production to disk and then executes it, and then hopefully deletes it, you just run that through a DOS-based compression technology like APAC or something that would compress COM files, because at that point you've got a COM file. So that was a way of getting around the limitations you had with the executable. And it takes some pain. Like a lot of these ones have inline assembly anyway. I think most of them have inline assembly for certain optimized routines. Blobzilla, the blob in the lower left corner, has assembly, like fairly detailed assembly for the blob routine.
You also rewrote the whole audio in assembly.
Ethereum I did.
Ethereum?
Blobzilla, I don't know.
No?
We can look at the code after.
Yeah.
It's amazing.
Anyway,
after a while,
lot of
it
embedded.
becomes a bit of a mesh. But so what ended up happening as the scene changed, and you end up with things like Crinkler, which combines the linking with the compression. It becomes less and less poignant to hand code everything with assembly, because especially when you're using something like Crinkler, you might have this really awesome idea about, oh, you know what, I'm going to store this data, and I'm going to do this algorithm that's really nifty, and it's going to store these edges and things of this data. Rather than repeating chunks of code, I'm going to boil it down, I'm going to roll this up, I'm going to make a loop out of it, and at that point you have done the most evil thing you can do to Crinkler. Because Crinkler absolutely loves to chomp down on repeated things. And there's nothing more painful. I love it, don't get me wrong, but it really stinks when you sit there, you think in the middle of the night, oh my goodness, I can shrink my production by this many bytes. You write the algorithm, and it is smaller in executable size, right? But when you end up putting it through a compressor, you get schooled on the rules of entropy and the fact that your new approach is actually harder for the compression to deal with. So most of our stuff now is just straight up Visual C type stuff, not really any C++ elements to it. A little bit of inline assembly, but
as few as possible.
Yeah, where necessary, because especially if depending on your framework, you may not have access to things like, you definitely don't have access to random number generation unless you're doing some shader stuff there. You may lose access to a number of the math libraries and those functions, so you need to build those your own way.
So anyone else? Hands up.
How much code can you reuse between productions, and how much do you have to write from scratch?
That's a good question. I think that at least our development process has always been to ask, hey, can we do this? I just ordered 3 glasses. Let's do something fun with that, right? Obviously, we have an inherited framework, and I've been changing the framework over time, but the framework isn't really all that big or complicated, right? It just allocates the window or the full screen, creates a messaging pump, and in fact, I didn't get into it at the time, unfortunately, but our framework, all it does is that. It draws a triangle, and I'm a coder, so I use coder colors, But that's basically it. It's like, did I get here or not type of thing. There has been, we have had the opportunity to reuse a little bit of stuff, but usually for the most part, it's build something, and then what you end up reusing is your experience more than anything else, right? The experience, every time, it's always a work in progress. It's like, oh, I built this, and that was cool, that was a neat way to do it, and then you put that in your toolbox of future tricks and that type of thing, and you may pull that out again, or you may not, or you may decide, oh, that was really evil, and I don't want to do it that way again, I didn't like the way I built it. It's a push and pull thing, right? Because people, they blow up on the launch pad. They want to make something, but they get so afraid to make the wrong thing that they make nothing at all. And our most successful demo engine, like the full-blown demo engine, I went to Assembly 2001, wrote an absolutely horrible, I do not want to admit that we did it, but production, but that's how we got our start. The second version of our demo engine, we didn't release a single production with, but it became a proof of concept, and it became entirely throwaway, which was the most brilliant thing that we could do. And then we had the third version, which a lot of our productions, as demos, not intros, but as demos, have been based upon. So.
So anyone else still? Okay.
Have you ever experimented with runtime code generation?
I think we did. ASCII did some of it.
Yeah, well, actually, one of the things, oh, come on.
Yeah, yeah.
Okay, so the particle effects on this cube right here. So this is called CubeTro, and remember I mentioned that was the one that was 12 bytes, 12 kilobytes, pardon me. Woo, 12 bytes, that would be awesome. CubeTro came back from the idea of, hey, let's animate a Rubik's Cube, you know, flying through a world type of thing, and see if we can solve a Rubik's Cube. And the way that we ended up approaching that problem is we just took a Rubik's Cube that was already solved, proceeded to put all kinds of transformations on it, and then we just played back the transformations backwards, so you go back to a solved Rubik's Cube. But each side of that Rubik's Cube is running for lack of a better term, like a virtual machine, like a bytecode machine, that's running a script that we designed that had an effect language on it. And when I said, you know, we had, you know, small opportunity for reuse, that's the only thing I can think of that we've ever reused, because we had another production around the same time that we used the same machine for, and we ended up using the same type of machine for that type of effect. Outside of that, typically, you have to be careful how intelligent you try to get to it, right? Because the compression algorithms that are there are really, really sophisticated. You know, they're memory hogs. They use a lot of CPU, but it's 4K, right? So, you know, it's absolutely a perfect application for it. And honestly, I think that outside of like native code, if you're starting to do those types of things and so on, you probably lose out in the end, and you might drive yourself a little bit nuts, just like, you know, I have, where you think of an awesome algorithm, you implement it, but try. Like, you know, don't hesitate to try.
Yeah.
You know.
But usually, simple data is much better than compresses, unlike complex code. Another example of that is, at one point, made a drum beat generator with funky drum beats. But it took much more room than if you would just store a track. So you got to be careful. But the best thing to do is do both and take the winner.
So anyone else still?
All right, well, if there's no other questions, I have one for the audience. Is there a Santa Claus now, Jim? I think so. If you lose a tooth, we'll find out.
So thank you, guys.
Thank you.
Thank you.